Question number 76. Which of the following can show geometrical isomerism? Just have a look on the given options. You need to just identify which of them can show geometrical isomerism. It means either they can form cis and trans isomers, or they can form syn or NT form, or EZ conformation. Either they can form cis and trans isomers, or they can form syn or NT form. That you need to just identify. For this, I have drawn here the structures of the given alkenes. In first case, if you look at here, you will observe that different groups are observed here, but this molecule is a non-planar molecule, and that's why we cannot say that it is showing geometrical isomerism. After that, if I talk about the next structure, here you can clearly see this is triene, and in this case there are two hydrogen atoms which are the same groups, and due to which it is not able to show geometrical isomerism. So I'll just mark here a cross for this and this also. Let's take the next option. We have this type of alkene in which there are two groups. One is hydrogen and this is methyl group. But if we talk about this carbon atom is attached with the same group at both the sides, it means in this case also geometrical isomerism is not possible. I'll just cross it. After that, the fourth option, just have a look on that. This is given here, this is oxime, and in this case, if you look here, you can draw that these two form. This is the syn form and this is the NT form. The lone pair of electron is present here. Along with that, OH is at this side, and similarly you can form its NT form also, and these two structures you will obtain. That's why it is that compound which can show geometrical isomerism. So definitely if it is asked to choose that one which shows geometrical isomerism, then you should choose option 4. Now, after this, let's take next question. Now, question number 77. Which of the following set of groups can show plus R effect is generally shown by those compounds on which lone pair of electron is present? So, let's have a look on the given groups here. This is OH group. We know that on oxygen atom there are two lone pair. It means it is showing this plus R effect. Further, NH2. Nitrogen also has a lone pair of electron. That's why it is also able to show plus R effect. But if I talk about this CHO group, this can be represented as this way. And this carbon does not have the lone pair. That's why it is showing minus R effect, not the plus R effect. So that's why I'll mark here a cross. Further, CN. Here's carbon, nitrogen, triple bond, nitrile group it is. And here is no lone pair on this carbon atom. That's why it is not a plus R group. For the COOH, if we talk about, this is also minus R group, not the plus R one. And further, minus CH2. It is a plus R group. But this is not the correct option because these two are not the plus R groups. Further, OR. Yes, it has the lone pair on this oxygen atom. It can show plus R effect. Now further, NHCH3. Nitrogen atom has a lone pair. And here is NHCOCH3. Again, nitrogen atom is there and at which lone pair is present. It means all three are showing the plus R effect, and that's why this is the correct answer. But before that, we have to check the next option also, COCl. The COCl is the acyl derivative that you can show in this way. This is again the minus R group, not the plus R group. For the COOCH3, this is ester group and it is also considered as minus R group. Further, CH3. The CH3 is showing hyperconjugation. Our correct option we already chosen, that is option 3, in which all the groups are there which show plus R effect. That's why answer is option 3. Let's take next question. In Kolb's electrolytic method, the gas produced at cathode is. During Kolb's electrolytic method, there is the release of H plus ion. Those get reduced at cathode to evolve hydrogen gas. And that's why the correct answer becomes option 1 for the question number 78. After that, there is another question. That's question number 79. Here's the reaction sequence that you can clearly observe. Acetylene is here. It is treated with ammonium chloride and Cu2Cl2. There's the formation of a compound A. Further, one equivalent of hydrogen is added in the presence of nickel catalyst. It means reduction is there, and there's the formation of compound B. When B is treated with HBr, another compound C is formed as the major product. You need to just identify what is C here. So in this case, I'm just going to write here the reaction that's taking place. This is acetylene, attack of NH4Cl and Cu2Cl2. There is 1,2 addition, and that results in the formation of a compound that has 4 carbon atoms. This is formed here. What you are going to do here, in this case you are just going to add one equivalent H2 in the presence of nickel. It means this triple bond will change into a double bond, and that results in the formation of a diene in this way. This is the diene that's formed here. Now, after that, you are just adding HBr. You are adding, and what's the temperature? That is minus 40 degrees Celsius. What would be the product that's formed here? In this case, the product formed is CH2, CHBr, CH3. That's the Markovnikov addition. And this is formed as the major product after Markovnikov addition. And where this alkene is given? This is given here in option 2. Just choose it as the correct option. Let's take next question. Question number 80. You have this compound X. It is treated with water in the presence of HgSO4 and H2SO4, and further it is heated also to obtain Y. This Y is an aldehyde. In the above reaction, X could be. Basically, this is the reaction in which there is the formation of Y, that's an aldehyde. This is the process of hydration of alkyne. So here I am just considering that the alkyne is acetylene. And what you did, its hydration is done. HgSO4, H2SO4, it is added to it, and this is forming this type of compound. And what will happen? There is tautomerism, and after this there is the formation of an aldehyde, and that you can represent as this. So where this product is given, this product is correctly given here. This aldehyde is formed. Now, if this is Y, then what was X? Definitely X is acetylene. And I'll choose this as the correct option. That's given here in option 2. After this, let's take next question.